Section 5.1 talked and introduced the concept of systems of equations, and we said that a system of anything is two or more. So a system of linear equations is two or more lines that are graphed on the same coordinate plane. When you're asked to find the solution to a system, what you're asked to find is the point, which is in the format x comma y, of intersection. So what we're dealing with in section 1 was graphing. And so basically what you did is you took the two lines and you either put them in y equals mx plus b or in another form so that you could actually graph them, and you can find their point of intersection by literally looking to see what the point was. We did a couple of questions, however, gives you some questions that are a little bit difficult to find the point of intersection, either because the point is really far up or down and it's just hard to actually find it. So today we're going to talk about two different ways that you can actually solve a system of equations without graphing. The first method is called by substitution. So these are the steps. You solve for a variable in at least one of the equations, substitute it into the other, solve to get the answer for the first variable, substitute that value, and then write the values as an ordered pair. This is going to make a little bit more sense as I explain it. Let's say that we have this equation system, this system of equations right here. Now granted, yes, we could graph it and we could see where they intersect. However, when two lines intersect, what they're telling you is that, and this is the very important key concept, the point of intersection is the x and y value that satisfy both equations. So that means when you have two equations and you know that you're looking for the x value and the y value that make both of them true, then you know that you can actually solve equations by using the equations as part of the solution or as part of the process. Here you're being told that y is equal to x plus 3. Here you're being told that y is equal to 2x plus 5. Well, if you know you're looking for the y value that is the same for both, then you know pretty much, kind of like a circular statement, if y is equal to this and y is equal to this, then you know that this value must be equal to this one, because both y's are looked at for being the same. You're looking for the point where both x and y values are the same for both equations. So you're going to set each equation, if it's equal to y, for example, if you know y is equal to this, and at the same time y is also equal to this, then you know these two must be equal to each other. Think of it this way. If A is equal to B and B is equal to C, then A must be equal to C, right? That's kind of a circular statement there. So you have x plus 3, which is what y is equal to 2x plus 5, which is also what y is equal to. Now you have an equation with only one variable, x. Solve for that variable like you know how to do. Let's subtract x, and remember there's lots of different ways you can do this. I'm just going to do it this way. 3 is equal to x plus 5. Now I'm going to subtract 5, and I'm going to get that x is equal to negative 2. Remember, you're looking for the solution x comma y. So what you're looking to find is also the y value, because your solution is going to be a point. So here I have x equal to negative 2. So the solution so far I know is negative 2 comma something, because it's x comma y, your solution set. So now that you know that x is negative 2, and you know that this x value of negative 2 is what it is equal to here and it's equal to here, you choose one of the two equations to plug that into so that you could get the y value. Let's plug it into this one. If I know that y is equal to x plus 3, and I know x is equal to negative 2, then I know y is equal to negative 2 plus 3, which is equal to 1. So your y value is equal to 1. That means your point is negative 2 comma 1. Now you don't always want to just leave it like this. You always want to check your work to make sure it makes it true. You plug it back into both equations. Take the first equation. Y is equal to x plus 3. that means that 1 must be equal to negative 2, because that's what x is equal to. I'm plugging y into y and x into x, plus 3. Sure enough, yes it is. Now we plug it into the next equation, to the second equation. Notice it takes like 2 seconds. Y, which is 1, must be equal to 2 times x plus 5. 2 times negative 2 is negative 4, plus 5 is equal to 1. So I know that this is my solution that satisfies both equations. Let's look at B. System of equations, because you have 2 of them. In this equation, it's telling you what x is equal to. In this equation, it's telling you that x is added by 8y, and then it gets you 16. Well, if you already know what x is equal to, you just take that x value and plug it in there. So you get 2y minus 4, which is what x is equal to. You don't need to put it in parentheses. Plus 8y is equal to 16. The purpose of doing this is so that you have an equation where there's only one variable, because when you have 2 variables in an equation, you can't solve. You have 2 unknowns, you can't solve. And so now you plug this in, so you only have one variable that you're solving for. Solve like you know how to do. Combine like terms. That gives you 10y minus 4 is equal to 16. Add 4 to both sides. You get that 10y is equal to 20. Divide by 10. You get that y is equal to 2. Remember, the solution to a system of a system of equations is going to be always a point, x comma y. So now that you found the y value, you're going to take that y value and plug it into one of the equations to get what the x value is equal to. This equation is the easiest to do that with because it tells you x is going to equal whatever this is, and you already know that 2 is what y is equal to, so you plug it in there. So in order to get the x value, you're going to go ahead and plug that in, and you're going to get x is equal to 2 times y minus 4, where y is 2. You go ahead and perform your operations. 2 times 2 is 4, minus 4, 0. So x is 0. So 0, which is what x is equal to, comma 2, is the solution. Check your work real quick. Plug 0 in for x. Plug 2 in for y. Two times 2 is 4. 4 minus 4 is 0, so that one's correct. Plug it in here. 0 plus 8 times 2. 0 plus 16 is 16. That's also correct. So you know that the solution is 0, comma 2. So both of these questions that we had a y value or an x value that was solved for, or more than one, so that you knew what x was equal to or what y was equal to, so you could substitute things in. Let's look at this example here. In this example, they're asking you to solve by substitution, but when you look at both equations, you notice that neither of the 2 equations is solved for a variable. It doesn't say x equals something or y equals something so that you can plug that value in. And so what you need to do is actually take one of those 2 equations and treat it like a literal equation that you learned how to do at the beginning of the year and solve for one of the variables. The only difficult part is going to be for you trying to figure out which equation and which variable is it easy to solve for. Well, looking at these, it appears that this one is the easiest to solve for because it's easy to get y by itself. So when I do that, I'm going to add 2x to both sides. So I get that this equation is the same as y equals 2x plus 8. Now that I know what y is equal to, I could take that y value and plug it into the other equation's y value. Important, make sure you plug it into the other equation, because if you were to plug it back into itself, you're going to get something that is like an infinite solution because of the fact that it's the same equation. So make sure that if you solve for one variable in one equation, you plug that value into the variable of the other equation. Okay, so now let's continue with this. So now I'm going to take that equation, 3x plus 2y y equals 9, and I'm going to plug in that 2x plus 8 into the y value. Definitely use parentheses here, because if you don't, you're not going to distribute properly. Remember, you're multiplying 2 by the entire 2x plus 8, so that's why you put it in parentheses. We go ahead and solve like normal, plus distribute 4x plus 16 equals 9. Combine like terms. Subtract. We're solving like we are experts at doing now. 9 minus 16 is negative 7. Divide by 7, and you get that x is equal to negative 1. Okay, we know now that x is negative 1. So my answer is going to be negative 1 comma something. And take that negative 1, which is what x is equal to, and you plug it back in to the equation that tells you what y is equal to. Now, many times you're going to hear, make sure you plug it back into the original equation. That is absolutely true. You do want to do that when you have a complex original equation that you transformed into a different one, because you might have made a mistake in becoming this equation. So it's really important that you do go back and put it into the original one. In this case, I'm going to go ahead and put it into the original one, because you never know. Maybe I quickly solved it and got y equals 2x and I did this incorrectly. As I'm looking at it and reflecting on it and being mindful of it, I'm sure that this is the correct form transformed of this. But in the middle of a summative or in the middle of a test where you're getting asked to do this, you have to remember that you're under stress. And so it's very possible that you would have made a mistake. So we're going to go ahead and instead of plugging it into that equation that we transformed, we're going to plug it into the original equation just to make sure that we don't make a mistake. So that one is negative 2 times x, which is negative 1, plus y is equal to 8. Negative 2 times negative 1 is 2, plus y is equal to 8. Subtract 2 on both sides, and you get y is equal to 6. So, in theory, the y value is 6. But don't just assume that that's correct. You always want to check your work. These types of questions you should never, ever get wrong, because you have an opportunity to check to see if it makes sense. So we plug it back into the original equations. So I'm going to go ahead and plug those in there. So I get negative 2 times x plus y equals 8. I'm going to plug both negative 1 and 6 into the x and the y. 2 plus 6 is 8. Cool. It satisfies the first equation. Now we do it to the second equation. 3 times x plus 2 times y equals 9. Well, x is supposed to be negative 1 and y is supposed to be 6. 3 times negative 1 is negative 3. 2 times 6 is 12, and negative 3 plus 12 is equal to 9. So I know that the point satisfies both equations. If it only satisfied one equation and this one was false or vice versa, that point would be incorrect and you'd have to go back to make sure that you've done it correctly. The good thing, once more, don't be lazy. Check your work because it will tell you whether it's correct or wrong. All right, what is anything without word problems? The reason we use word problems isn't to give you anxiety. It's because this is where you see it in the real world. We're always asking, well, when am I going to use this in the real world? This is where you're going to use it. Hopefully at this point, you guys have seen all of the things that you have learned in Algebra 1 and in pre-algebra. All those things that you thought, well, when am I going to use this in real life? Well, you're going to use it for systems of equations. And when am I going to use systems of equations? When you have an equation or a word problem or an actual real-world problem like this. One cable television provider has a $60 setup fee and charges $80 per month. Per. Remember, when you see per, that's going to be the one that's being multiplied by something. So that's like the times something. And another provider has a $160 equipment fee and charges $70 per month. All right. How many months will the costs be the same? What will the cost be? If you plan to move in 6 months, what is the cheaper option? First things first, you have to make sure you always identify your variables first. It is going to be your job to choose what variables you're going to use for what unknown quantity. So what are the two things that we're talking about? We're talking about, the setup fee, but the setup fee is a fixed cost. It's not going to change. That's just flat $60. Same thing with the equipment fee, fixed. When something is fixed, it is constant. Remember what the word constant means in an expression? It's the one without the variable because it's the same, it doesn't change. So these two right here, the $60 setup fee and the $160 equipment fee, are the ones that are fixed and don't change. So we're talking about two different television providers. Let's say television provider number 1 and television provider number 2. Television provider number 1, your cost, so let's say that Y is your cost because it depends on X, the number of months. So provider number 1, the cost is equal to the $60 flat fee plus the $80 per month. So that's the $80 per month. You're going to pay, and when you get stuck as to who is what in terms of X and Y, ask yourself, well, if I had this company, what would I pay? I would pay $60 plus, really it depends on how many months. So $80 multiplied by the number of months, that's where we get this. Okay, television provider number 2. Your cost is equal to the $160 flat fee or equipment fee plus $70 per month. And we said X is the number of months. Could you have used different letters? Absolutely. You could have said C is for cost, and you could have said M is for months. I always like to keep it as X and Y because I know that this is equations that I'm going to be graphing, because I know that what they're asking me for is based off of X's and Y's. And it also just makes it run easier so that when you look at the equations that you've created, you can see that they're both in Y equals mx plus b. So now that we have the two equations, they're asking you in how many months will the costs, so that's the Y value, be the same. So they want to know, when is this Y value going to equal this Y value? So your job is to literally put it into an equation that's going to find out when this is going to equal the 160 plus 70x. You want to know when TV company 1 is going to equal TV company 2 in the cost. Well, that purple beautiful equation is actually a one variable equation. You're going to solve. I'm going to subtract the 70x. That's going to leave me 60 plus 10x is equal to 160. Now I'm going to subtract the 60 on both sides, and I'm going to get that 10x is equal to 100. I'm going to divide by 10, and I'm going to get that x is equal to 10. Now remember, this x is really the number of months. So what I am stating in x equals 10 is that in 10 months, the cost of TV company 1 is going to equal the cost of TV company 2. Part B. Okay, so that was part A. We just answered part A. Part B. Part B says, if you plan to move in 6 months, which is the cheaper option? Well, the months that they're discussing is X. So they want to know, let's see, what is the cost going to be, this is part B, for TV company number 1, if I move in 6 months? Well, the cost is going to be 60 plus 80 times the 6 months. That's going to give me 480 plus 60, which is $540. y is going to equal 540 at TV Company 1. TV Company 2, the cost is going to equal 160 plus 70 multiplied by the 6 months. 70 times 6 is 420. 420 plus 160 is 580. So, which of these is cheaper? TV Company 1, because it only costs $540, as opposed to TV Company 2, that would cost $580 for 6 months. So the cheaper option is going to be TV Company number 1. These types of problems are the types of problems that you are going to see very often, not only in the real world, when you actually are trying to make decisions, but in your academic career when you move through mathematics. So lots of these types of questions. Your job, most important job, is going to be to make sure that you identify your variables. Because when you identify your variables, it's much easier to translate from words to math. So always identify your variables. Okay, we're going to go ahead and you guys are going to work on your independent practice. But we're going to go ahead, I'm going to go through this. These are all the systems of equations solving by substitution that you are going to practice. But now we're going to go straight into solving systems by elimination. So now let's recap real quick. Number 1, we learned how to solve systems by graphing. Number 2, we learned how to solve systems by substitution. And the way we did this was made sure that you had either y equals something or x equals something, and then plug that in to one of the equations. The third way of solving is solving systems by what we call elimination. Now, you would use the solving systems by graphing if you were given a choice. You would use solving systems by graphing when it's really easy to graph, when you have two equations in y equals mx plus b, where you know you can quickly and easily graph them with the y-intercept and the slope, and then find their point of intersection. If, however, you had two equations where you don't have them in y equals mx plus b, maybe only one of them is in y equals mx plus b, or one of them is in x equals something, then you would substitute, because it would be easiest to just plug that value of x into the other equation's x value to get y, and vice versa. But sometimes you're going to have a system of equations where neither of the two equations are written in y equals mx plus b or y equals or x equals, such as this one here. That is when you would use elimination. So these are the steps for solving systems of equations by elimination. The first thing you do is you write them so that the terms are aligned. You eliminate, get rid of, that's what elimination means, to get rid of one of the variables and solve for the other variable. Then you substitute the value back in, and then you write the answers as an ordered pair. The purpose of elimination is to get rid of one of the variables so that you have just a one variable equation. And when you have a one variable equation, the good thing is that then you can just solve it, because it's easy to solve a one variable equation. So you will get the hang of this. If you're getting a little bit confused, I want you to make sure that you just keep practicing. This is some of those things that are just, it makes sense, common sense. It's logical once you really start practicing. So in this example, they want us to solve this system by elimination. To eliminate means to get rid of. So when you see the word elimination, you're going to think, get rid of a variable. Your job is going to be to figure out which variable am I going to get rid of. Well, when you're looking at the system, always look to see how to get rid of a variable by looking for opposites. The way to get rid of things is with their inverse, their opposite. If I have 6, the inverse of 6 is -6, and that cancels out. And so what you're going to be doing is looking for opposites in the terms of the system within them. Hopefully at this point you recognize that here we have opposites. We have a positive 3y and a negative 3y. So what you're going to do is you're going to combine these two. Once you have opposite terms, you are going to add straight down. Literally, add the two equations. 1x plus 3x is 4x. Negative 3y and positive 3y cancels out. 7 plus 9 is 16. So you now have the equation 4x equals 16. Divide by 4, and you get that x is equal to 4. If you know that x is equal to 4, then you can plug it into one of those equations. Let's put it in that one because that one's pretty easy. And solve for y. So if x minus 3y is equal to 7, and I know that x is equal to 4, then I can substitute 4 into that x. And when I do that, I now have an equation that is literally just one variable. And that one variable in this case is y. So now I'm going to solve. 4 minus 3y is equal to 7. To solve for y, I'm going to subtract 4 on both sides. And I'm going to get negative 3y is equal to 3. I'm going to divide by negative 3, and I get that y is equal to negative 1. So now I have my proposed point. X is 4, y is negative 1. Don't forget, always check your work. So we're going to plug those values back into both equations. Let's see. This is my check work. 4, which is x, I'm using this first equation, minus 3 times y equals 7, where y is negative 1. 4, this becomes plus 3 equals 7. Yes, so I know it's correct for that one. Now I do it for the second one. 3 times x plus 3 times y equals 9. Well, x is supposed to be 4 and y is negative 1. 3 times 4 is 12. 3 times negative 1 is negative 3. 12 plus negative 3 is 9. So I also know that's correct. Therefore, this beautiful point is the solution to that system of equations. So remember, step 1, look at the two equations. Step 2, are there any opposites already? Yes, add down, solve, plug in, get the other value, check your work. So, well, what happens when you don't have opposites? It's not an immediate opposite such as this one. In this case, you notice that you have close to opposites. You have a negative 3y, but this one's also negative. If you were to combine those, if you were to add these down, you would get negative 6y. So in order to get rid of one of them, remember, you're allowed to do anything to an equation as long as you do it to the entire equation. Best thing to do, multiply one of these two equations by negative 1 so that it changes the sign, and now it's opposite. I'm going to choose the bottom one. You could have multiplied the top by negative 1 if you wanted to. That's fine, but I'm just going to do the bottom. That's going to give me negative 5x plus 3y is equal to, remember, you have to do it to everything. Don't forget that 14, negative 14. Now that I have the equation transformed to the opposite, I'm going to rewrite that top equation and add down. Negative 5 plus 2x is negative 3x. The y's cancel out. Negative 4 plus 11 is negative 3. Just a little note. Remember to add. You're combining the two equations because you want simultaneous points. You want the points that together give you solutions for both equations. So add down. Okay? Divide back to our equation to negative 3, and you get that x is equal to 1. Now you take those value of x and plug it into one of the two original equations. I'm just going to choose the top one. So the top one is 2 times x minus 3y equals 11, where x is 1. 2 times 1 is 2, minus 3y is equal to 11. Subtract 2 on both sides. Negative 3y is equal to 9. Divide by negative 3. Y is equal to negative 3. So my proposed point solution is x is 1, y is negative 3. Before I circle it, I'm going to check my work. So the top one, 2 times 1 is 2, minus 3 times negative 3, which is this part here. 3 times negative 3 is negative 9. And then together, the 2 minus negative becomes plus, and 2 plus 9 is 11. So you know that it satisfies this one. Now we do it for the other one. 5 times 1 is 5, and minus 3 times negative 3, well, 3 times negative 3 is negative 9, but there's a minus in front, so 5 plus 9 is 14. So I know that this is my solution because it satisfies it. Both the top equation and the bottom equation. So, first of all, make sure that the terms are aligned. So x's are under x's, y's are under y's. Eliminate one of the variables, solve for the other variable, and the way to eliminate one of the other variables is to add down. And then plug in and try. Let's look at this one. Now there's sometimes, as you see here, where you're going to have to do more than just multiply by a negative. Always look to see which is the easiest to get opposites with. Well, this guy's negative and this one's positive, right? They're already x's under x's, y's under y's. So I can actually multiply this equation by positive 3. And then that would become negative 3x. So we would get 3 times negative x is negative 3x. 3 times y is positive 3y. And don't forget this one over here. Everyone always forgets that. 3 times negative 2 is negative 6. Rewrite the top equation. 3x plus 2y equals 6. Now you're going to add down. That cancels out. 3y plus 2y is 5y. Negative 6 plus 6 is 0. Remember that zeros are numbers too. Do not discriminate zeros. Divide by 5. 0 divided by 5 is just 0. Now you're going to plug that value of y into one of those two equations to get the value of x. Let's put it into this one. The reason I chose this one is because this one has 3 times x, so at the end I'm going to divide by 3. This one, it's negative x, so I'll have to divide by negative 1, but either one, it would work. It doesn't matter. You get to choose which one you want to plug it into. I'm going to plug it into the bottom one. Negative x plus y is equal to negative 2. Put the 0. Negative x plus 0 is just negative x. So if negative x is equal to negative 2, then x must equal positive 2. So my proposed point is x 2, comma, y 0. Check your work. I am going to check my work by plugging 2 in here and 0 in here. 2 times 0 is nothing. 3 times 2 is 6, so I know it's correct. Put in a 2 here. Put in the 0 here. Negative 2 plus 0 is negative 2, so it's correct. So I know that my work is correct. So the difference between this question that we just did and the question prior to that is that with this question, we had to multiply by an actual number. We had to multiply by 3 to get it so that we have opposites, so that we could eliminate. Let's look at this one. Try to eliminate. Well, I have a negative of an x and a positive x here, so these guys are opposites. Oh, but so are they here. 5 and 4 are not the same number, but one's positive and one's negative. You can actually choose either one, either x or y, to eliminate. If you do it properly, you will still get the same answer. You choose the variable to eliminate. And if you want to eliminate x and I end up eliminating y, you are still going to get the same answer. I always look at the first term, so I look at x. How can I get 2x and negative 3x to be opposite number, to be the same value? Well, I can make this positive 6 and this negative 6 very easily because their least common multiple is 6. How do I make this positive 6? I would have to multiply by 3. But whatever you do, you have to do it to the entire equation. So I'm going to multiply the first one by positive 3. If I multiply the first by positive 3, the x would become 6x. So now I have to look at the bottom one and go, well, what do I need to multiply him by so that he is, just like this one gives you 6x for the first term, it would give me negative 6x. I would have to multiply by 2. That would give me negative 6x. So when you go ahead and distribute, and remember you do it to the whole equation, you get 3 times 2x is 6x. Then you have 3 times 5y is 15y. That's going to equal 3 times 26, which is 78. Now I distribute the 2 to the second equation. 2 times negative 3 is negative 6x. 2 times negative 4 is negative 8y. 2 times negative 25 is negative 50. Now I'm going to add down. So step 1, get a variable to eliminate. Step 2, add down. This cancels out. 15 minus 8, 15 plus negative 8 is 7y. And 78 minus 50 is 28. Now I divide by 7, and I get that y is equal to 4. After you add down to solve for a variable, you are going to substitute the value to get the second variable solved for. So choose one of the two equations. It doesn't matter. Original equations. Look at the original equations. I'm going to choose the top one because there's less negatives. 2x plus 5 times y equals 26. Put the y value of 4. 2x plus 20 equals 26. Subtract 20 to solve. 2x is equal to 6. Divide by 2. X is 3. So my proposed point solution is x of 3, comma, y of 4. Check your work. I'm going to plug in x for 3 here and y for 4 here. 2 times 3 is 6. 5 times 4 is 20. 6 plus 20 is 26. Satisfies the first one. Negative 3 multiplied by 3 is negative 9. Negative 4 multiplied by 4 is negative 16. So this would be negative 9 minus 16, which equals negative 25. So I know that my solution of 3, 4 satisfies both equations. Therefore, it is the solution to the system. Your independent practice, notice here, it tells you to determine the method of elimination used. So basically, it's just asking you to eliminate, solve through elimination. This one, you would just add down, and the y's would cancel out, and you would get 2x here. So you're going to go ahead and complete the independent practice for this and the last one as well. So you're going to complete the independent practice for substitution and for elimination. Please remember to email me if you have any questions as you are completing these, and I will see you guys soon.